So in this example, I want to find the third Taylor polynomial generated by the function f of x equals the square root of x, centered at 4. I wanted to start by writing the general form for the third Taylor polynomial. So I started that out up here. So P3, which would be, so think of it as the zeroth derivative, which is the original function, evaluated at the center, which we're going to say centered at a, times x minus a to the 0, which is 1, plus first derivative evaluated at the center, which is a, over 1 factorial, which is 1, times x minus a to the first. Okay? And then second derivative evaluated at the center, which we're calling a, this is an a right here, sorry, over 2 factorial x minus a to the second. And then third derivative evaluated at the center over 3 factorial x minus a to the third. Okay, so that's the general formula, think of it, for the third Taylor polynomial. So now for this specific function, let me write the function off to the side here. So f of x is the square root of x, which can be expressed as x to the 1/2. So the first derivative would, according to the power rule, would be 1/2 x to the negative 1/2. Second derivative would be, so we've already got 1/2 out front, and then the negative 1/2 comes down. X to the, subtract 1 from the exponent, so minus 2 over 2, this will be to the negative 3/2 power. And then third derivative, so I'm going to go ahead and multiply these just to save myself a little space. So this is negative 1 over 4 when we multiply this coefficient that we already have. And then the negative 3/2 would come down. X to the, subtract 1 here, so subtract 2 over 2. This will be x to the negative 5/2. Okay, and now we're about to evaluate it. So I'm going to change this back to the square root notation. So this is the square root of x. This, so x to the negative 1/2. So that means that it's the square root of x in the denominator. Now this one here, so the product here is negative 1/4. X to the negative 3/2, so that's 3/2 in the denominator, which is the square root of x raised to the third power. And then this one, so the coefficient would be positive 3 over 8. And then x to the negative 5/2, so that's the square root of x in the denominator raised to the 5th power. Okay. So now evaluate these functions at the center, because that's what we're going to plug into the formula here for f of a, f prime of a, f double prime of a, and so on. So original function evaluated at the center, which in this problem is 4, would be the square root of 4, so that's 2. First derivative evaluated at the center would be 1 over 2 times the square root of 4, which is 2, so 1/4. Third derivative evaluated at the center, second derivative evaluated at the center would be negative 1 over 4 times, square root of 4 is 2, raised to the third would be 8. So negative 1 over 32. Here's the third derivative. So third derivative evaluated at the center would be 3 over 8 times the square root of 4, which is 2, raised to the 5th is 32. 2 to the 5th is 32. So what's that? 3 over, and there's no, it's nice to look for common factors to cancel in a scenario like this before the numbers get too big, but there are no common factors there. So what would this be? 240 plus 16, right? 256. Okay. So those are your coefficients. So this third Taylor polynomial, I'm going to erase the question that was asked here. We're ready to fill in the answer. I'm going to get my colored markers. Okay. So now we just plug in. So function evaluated at the center is 2. Okay, plus f prime, which is 1/4. times x minus 4 to the first. F double prime is this negative 1 over 32. So I guess I'll just plug it straight in for now. So this is negative 1 over 32 over 2 factorial, which is 2, times x minus 4 to the second. And then third derivative, so f triple prime at a, in this case f triple prime at 4, is 3 over 256 over 3 factorial, which is 6, x minus 4 to the third. Okay, so let's simplify what we can here. It's nice to make it as neat as possible. So our third order Taylor polynomial, centered at 4 here, is 2 plus x minus 4 over 4 minus, okay, so this 1 over 32 divided by 2 is going to be 1 over 64. X minus 4 squared. And then 3 over, I'm going to do a little scratch work over here, 3 over 256. So you can think of this 6 as 6 over 1. And so instead of dividing by 6, we can multiply by the reciprocal, which in that case I could cancel a factor of 3 here. So that'd be 512 then, when you double 256. So this will be, this coefficient here works out to plus 1 over 512, oops, x minus 4 to the third. Okay, and there's your third Taylor polynomial. If you like, you could type this into Desmos and then type square root of x into Desmos. Center your graph at 4, because that's where this polynomial is going to be. Think of it as a polynomial approximation of that function. It's going to be most accurate close to 4, because we centered this polynomial at 4. But this here would be your answer to this example, the third Taylor polynomial for square root of x centered at 4.